Today, we're going to pull back the curtain on your computer's real superpower, multitasking. We're going to find out how it juggles your browser, your music, and, dozens of other things all at once without even breaking a sweat. So, let's dive in. Think about it. It's something you do a million times a day without a second thought. But in that tiny little gap between your click and the app popping up on screen, there is this whole hidden world that just springs into action. It's not magic. It's this incredibly fast, really complex ballet happening right inside your machine.
So that one little click, it kicks off this amazing transformation. It takes a simple, kind of lifeless file that's just sitting on your disk and breathes life into it. It turns it into something active, something your computer can actually do something with.
Okay, so here's the most important thing to get your head around: the difference between a program and a process. A program, like that icon for your web browser, is kind of like a recipe in a cookbook. It's just a set of instructions sitting there totally passive. But a process? Well, that's you in the kitchen, actually cooking the meal. It's the program in action. It's alive, it's running in memory, it's using up your computer's resources.
Just like anything else, a process has a life cycle. It has a story. From the second it's created to the moment it's done, it moves through these very distinct stages. So let's follow along on its little journey through these 5 states of being.
So every process starts its journey in the new state. Boom, it's just been born. Right after that, it moves to the ready queue. Think of it like a runner at the starting line, just waiting for the gun to go off. When the CPU finally calls its number, it jumps into the running state and gets to work. Now, if it needs something, maybe it's waiting for you to type something, it goes into waiting mode, basically taking a little break. And once the job is all done, it hits the terminated state, and that's it, life cycle complete.
Now, you might have hundreds of these processes all living out their lives at the same time. It sounds like chaos, right? So how in the world does the operating system keep track of it all? It can't just let them run wild. It needs a way to manage every single one.
And the answer is something called the Process Control Block, or PCB for short. The best way to think about it is like an official ID card for every single process. It's this super important data structure where the operating system keeps all the details it needs to manage that process.
So what's actually on this digital ID card? Well, it's got a unique process ID, the PID, so it doesn't get mixed up with anyone else. It keeps track of its current state. Is it running, waiting, what's it doing? It also holds the program counter, which is basically a bookmark that tells the CPU exactly which line of code to run next. And it saves the CPU registers, which are like the process's short-term memory. It is, for all intents and purposes, the complete personnel file for our busy little process.
Okay, so we've got all these processes, each one with its own ID card, all lined up in that ready state, just itching to get some work done. But there's a bottleneck, right? You've got way more processes than you have CPU cores. So how does the operating system, the ultimate manager, decide who gets to go next?
This right here is where the real magic of multitasking happens. It's a trick called context switching. I want you to picture a manager on an assembly line who can swap out workers at lightning speed. The operating system saves the exact state of the process that's running, everything, into its PCB. Then, in the same instant, it loads the state of the next process from its PCB. This switch happens thousands of times a second, and it's so fast that it creates this perfect illusion that everything is running all at the same time.
So let's talk about the bookends of a process's life, the very beginning and the very end. A process doesn't just pop up out of nowhere. It's usually created by what we call a parent process. Your web browser is the perfect example. The main browser window is the parent, and every time you open a new tab, it spawns a brand new child process just for that tab. You end up with this whole family tree of processes all working together.
And, just as there's a beginning, there has to be an end. A process can finish its journey in one of 2 ways. It can terminate normally, which is a nice, gracious shutdown after its job is done. Or it can be terminated abnormally. Maybe it hit a nasty error, or maybe you, the user, just decided to force quit the application.
So let's do a quick recap of this secret life we've been talking about. A program is just a file until it becomes a running process. That process lives its life through 5 different states. The OS keeps track of everything with the PCB, its personal ID card. And the whole magic trick of multitasking is pulled off by super fast context switching, making sure every process gets its moment on the CPU.
And that kind of brings us to a final thought. Your computer's operating system is an absolute master of efficiency. It juggles all these tasks with incredible precision, prioritizing, switching context, handing out resources without a single mistake. It really makes you wonder, if a machine can manage all its processes so perfectly, what could we learn from its methods from managing the millions of tasks in our own lives?